Welcome to Inner Talks. EtherCAT has emerged as an important technology addressing the real-time demands of automation systems. It's field-proven, widely adopted, very fast and cost-competitive against alternative fieldbus solutions. At the same time, we're seeing the increasing adoption of PC-based edge computing in industrial automation and the emergence of deterministic Ethernet capabilities using TSN. Today, I'm joined by two of Advantech's domain experts to discuss how EtherCAT dovetails into these other emerging technologies, and we'll also be hearing from some of our partners about how they use EtherCAT to give them a competitive edge. From our North American organisation, I'm joined by Joseph Yang, who's the Director of Product Management in the US. And from Europe, I'm also joined by Daniel Sun, who's the Product Sales Manager covering a portfolio of products which include our EtherCAT solutions. Gentlemen, welcome. EtherCAT's been around for quite a while now, so I guess it's pretty well known and understood. But just in case it's new to some of our audience, could we quickly define the problem that EtherCAT addresses, especially in the context of the new technologies that are emerging in automation?
Yeah, fieldbus technology is vital for automation. And we've moved from the era when PLCs were king. Now PC control is booming. High-performance PC controllers technology offers a very powerful CPUs, large storage capabilities, and the flexibilities on the network connectivities. And this is the reshaping automation. But there are still problems to be addressed. The bottleneck, legacy fieldbus systems are low bandwidth or very high jitter time. And these are limiting the overall performance of the PC control systems. Also, legacy fieldbus is not fully open. Many rely on proprietary standards, and so users are looking to a particular vendor solutions.
Yep, so I would think about two major factors here. So first one is about the deterministic. So in motion control applications, real-time performance is always a critical indicator when users select the solution. Within different industry Ethernet protocol, so I believe EtherCAT delivers the most deterministic performance so far. So this gets a lot of attention from automation market and give users more options when they plan for motion control application. The second one will be open technology. So usually users do not anticipate single vendor solution. So that limits options and delay the expandability when they need it. EtherCAT is adapted by many different companies and hardware vendors, although this is not good for a hardware vendor like us, but that is a huge benefit for users since they have lots of options. They do not have to worry about, they will become victims if original vendors do not support them well. So that can easily switch to any others. That's really a good benefit for users.
So what's holding back adoption today?
Well, it's the external dilemma for the automation system operators. Considering the ROI, the owners of the legacy systems prefers to upgrade a system gradually. And a completely changing legacy fieldbus would need huge investment on hardware and engineering tools. It's now easy for users to escape from a vendor-locking situation.
Yep. And I will think about two possible reasons here. So first one, new technologies always need more time to prove that it is solid and robust. Users need to get confidence before they would adapt. The second reason would be in the United States, we know we have a very strong and joint industry solution provider, so who has dominated the market for a long time. I would imagine how difficult and resistant to change the user's mind. I would think about a lot of educations and marketing initiatives that would be needed here. So if we can have more use cases here, I think this definitely will be a great booster to bring more customers in the United States.
Okay, so EtherCAT's potentially a big part of the solution here because it's well proven and mature, but as we'll come on to discuss, it also integrates nicely into the open platform approach which PC-based controllers are built on. Again, just for those in our audience who are still unfamiliar with EtherCAT, we thought it would be useful to have a quick overview of it from a technical perspective to understand how it fits into an architecture and provides real-time performance. Anis Arura leads our IIoT technical support teams in Europe, and we asked him to tell us more about the underlying technology from a technical perspective.
Thank you for the question. Let's talk about EtherCAT. EtherCAT is an Ethernet-based field system invented originally by Beacon Automation. Currently, many manufacturers use it as a standard communication protocol in their devices. It is a high-performance fieldbus, and it has the shortest cycle time. We talk about 276 microseconds. That's why it is perfect for real-time machines control. EtherCAT has a master-slave configuration. The EtherCAT doesn't work with the send-receive request like other Ethernet network. The master sends the data. It is a single frame for the entire network that will pass through each node. Each EtherCAT device processes only the frame's data that is relevant to it and adds its data to the frame. In the last node, an open port is detected, so the slave will automatically return the frame. EtherCAT implements a method called distributed clock system, while in other protocols the response time of each slave is the same. The common and the most common network topology is daisy chain because all EtherCAT devices usually have an input and output port. However, in most cases, EtherCAT supports other network topologies like tree, line, ring, and star. From the characteristic point of view, the data rate is about 10 megabits per second, and the number of slaves is up to 65,535 slaves. The maximum distance is about 100 meters. In Advantech, we propose different solutions based on EtherCAT protocol. There are many different master-slave configurations. Customer can easily integrate them. We offer a large scale of flexibility in both hardware and software level. I hope my introduction gave an overview about the importance of EtherCAT protocol in future automation system. As Advantech technical team, we are always available to advise, help, and support. Thank you very much.
Thanks, Anis. Okay, so what's Advantech's perspective on this?
Well, Advantech was born from PC control technology, and we are one of the pioneers supplying PC-based controllers to the market. And we are embrace EtherCAT from its very beginning. As we see the potential for the combination of performance and openness it offers, and be able to supplement our range of the high performance and high reliability PC-based automation controller with our FPGA-based EtherCAT master cards, EtherCAT I/O system, and EtherCAT junction modules. We are positioning as a completely open EtherCAT solution vendor, which allow us to cooperate with specialist solution suppliers who then leverage our enabling technology.
Advantech provides solid and comprehensive portfolio on hardware, especially IPC. So we have gained strong trust from customers. We heard from our customers that they would like to leverage our hardware to accomplish control application solutions. So to find partners and work together and offer robust solution is in our priority. Furthermore, workload consolidation is always a huge benefit that industry PC can well suited here. Of course, a matured control soft logic is needed here too.
Yeah, and I think there are two ways we do this. One's with focused channel partners who specialize in softPLC based solutions that sit on our hardware, and that kind of allows rapid development and deployment of general purpose applications. And the others through eco partners who provide an EtherCAT stack with open APIs for users to leverage in more specialized or niche applications. We asked a couple of these partners how they leverage the possibilities of EtherCAT. First, let's hear from Roberto Riccardi at Eruno.
EtherCAT, as you probably know, is a fieldbus, widely used in automation hand-in-hand. The main features of EtherCAT are easy to use, and implementation programming software. Example, to use EtherCAT, peripherals of different nature and even run within CPUs with codices programming software, simply import the relative XML file to automatically have a driver and configuration parameters. Speed. EtherCAT is real-time fieldbus with deterministic response times much slower than other no-fieldbus such as Profinet. This makes it suitable to be applied to many applications. I would also like to emphasize the importance of codices software. Codices is a very flexible development environment as the user can use 5 different languages based on the ESC 61131 standard and provides a real-time compile suitable for controllers with different processors and operating system. This makes it scalable and flexible. It's this combination of a flexible, standardized softPLC running on rugged edge hardware, together with the extremely fast and deterministic nature of EtherCAT, that has allowed us to rapidly develop and deploy a real-time solution for our customers.
And we're hearing a similar story from our North American partners. Here's Dave Locke from Motion AI.
Hello, this is David Locke, Division Vice President with Motion Automation Intelligence, or Motion AI. So what do I see as the differentiated value of a Codesys solution with Advantech products versus legacy alternatives? Well, first, you have a proven, robust softPLC running on open hardware versus a hardware PLC. Secondly, you enjoy the cost savings of a software motion controller for general motion, CNC, and robotics versus separate hardware motion controllers. Thirdly, you have soft visualization with locally connected monitors and touchscreens versus programmable hardware HMIs with different development environments. Also, you enjoy rich device data availability because you're using a PC to drive local and remote AI-informed decisions, including predictive maintenance. You have broad connectivity between machine controllers, to the edge, and to the cloud. And all this can be accomplished in a single development environment via Codesys running on robust Advantech hardware.
The second way our partners leverage EtherCAT is by providing a protocol stack that can be integrated into applications which can't be addressed using soft PLCs. We asked Stefan Zintgraf from Acontis to tell us more.
Thank you for having me in this InnoTalks. Many EtherCAT applications are based on PLCs and use PLC programming paradigms. But there are also markets and applications where PLCs do not fit or are not common. For example, semiconductor tool vendors, robots, or real-time measurement applications. And of course, PLC controller vendors themselves. These applications use C or C++ programming language and run on real-time operating systems which are significantly more powerful than a PLC runtime environment. But unlike PLCs, real-time operating systems do not offer EtherCAT support. Instead, a dedicated and high-performance EtherCAT master stack to communicate with the devices is needed. All EtherCAT features need to work well, and the stack must be compatible to all devices on the market. And the stack needs to support the operating system used by the customer. The Acontis master fits to all these requirements. It provides a well-defined, proven and stable C/C++ API with a great amount of sophisticated capabilities. The software is available for more than 20 operating systems. Acontis' own drivers optimized for EtherCAT assure highest performance and are provided for over 20 different Ethernet controller families. The master stack is completed by the Acontis Easy Engineer configuration tool. Acontis also provides complementary EtherCAT products. For network diagnosis, the Easy Inspector tool can tap the traffic and show what's going on in the system.
The Easy Monitor software library helps creating monitoring tools or cloud interfaces for predictive maintenance. The Easy Simulator simulates paths or the whole network in real time. This can help to increase product quality or to create digital twins. Customers can rely on Acontis as a provider for all software components needed to build sophisticated C, C++-based EtherCAT applications. Thank you.
Daniel and Joseph, EtherCAT sounds very interesting then from the perspective of allowing very tight control loops and other real-time interactions to be integrated into open platform controllers without the need for any proprietary solutions. This concept sounds like it would really have power when we combine it with the other open technologies in the edge computers. Is that right?
Yes, absolutely. We all are seeing the trend of the OT and IT integration for real-time automation applications. Many users are starting to investigate the use of the virtualization and the hypervisors at the edge. Thanks for the high performance we can now offer in this space. Applications can be implemented with software PLCs and include advanced applications based on the EtherCAT master stack. They can manage real-time tasks very well, but critically, the PC controller can also handle non-real-time applications like HMI or cloud communications at the same time, without compromising the system real-time performance.
To echo what Daniel just said, that's exactly right. So workload consolidation is always appreciated by users as long as the quality and the compatibility has been verified. The CPU nowadays could be way more powerful than before, and virtualization had been proved in quite some time as well. So it is the best moment to integrate and provide the benefits to users now.
It's interesting you talk about the emerging trends in industrial PCs, such as virtualization. Another thing we're hearing a lot about around IIoT is the emergence of TSN. And looking from a very high level down, both TSN and EtherCAT seem to be telling the same story: fast, deterministic, low latency, reliable comms. So what's the difference, and why should users be selecting EtherCAT now rather than waiting a couple of years for TSN to mature?
Well, EtherCAT is still the best performance on the real-time fieldbus. We see lots of discussions on like legacy fieldbus plus TSN can catch up the performance of the EtherCAT, but there's a long way to development of TSN on OT fieldbus. At the moment, we just see OPC pub sub plus TSN will become first available protocol, but it's not a real-time OT fieldbus.
Yeah, and presumably because of the single frame transmission mechanism Anis was telling us about at the start of this session, EtherCAT's always going to offer lower latency than we'll get from TSN, right?
Yeah, correct.
So what are we actually doing in this space right now?
Well, Advantech owns strong control PC and I/O portfolios for open EtherCAT solutions. So we are putting efforts to collaborate and pre-validate with our software partners like Acontis and Codices. Thanks for the openness and the no wonder lock-in position. Our solutions are used in like OEMs, like AGVs, automation, and also the robotic solutions, even the medical equipment.
Yep, I would like to address how we go to market in the United States here. So focus channel partner will be one of the approach. Of course, collaboration is so important in the IoT world now. Most of the users, when they look for solutions, they want a one-stop shop. So they get everything done. But not only hardware controllers, but also motors, actuators, sensors, IOs, and some peripherals even. So our focus channel partner, they can provide professional services since they had been in the industry for a long time. With such good and experienced partners, we have confidence we can support customers very well. The second approach will be, on the other side, we wanted to partner with soft logic solution providers in local. So not only for marketing initiatives, but also educating potential customers, provide comprehensive product information. And most critical thing is we can get the timely local support here as well.
Yeah, and we're already seeing partners having success with real-world implementations. Here's Roberto from Eruno again.
With regard to application with codices and EtherCAT real-time system, I would like to underline that in addition to the classic project in the automation, software motion, robotic CNC field, the system is also suitable for other less known but interesting areas and applications. For example, our latest project is test bench for naval components and fittings. The test bench consists of certifying and validating the fire test of components, for example, sail, that are to be placed on passenger ships. The test involves initiating the chair and measuring the environmental parameters of temperature, pressure, humidity, oxygen levels, fumes. The fast data acquisition in EtherCAT, and thanks to the 2 MB buffering of the CPU inside the WISE 5580 with codices, allow the real-time acquisition of parameters and subsequent processing. Through a connection from codices to SQL database, the data is stored in the server for the creation of the test report and relative certification. Another interesting use case is the use of the WISE 5580 with the codices software as the data concentrators in a hydrogen power plant. It's the case of the first ceramic factory completely powered with hydrogen in the world. Codices Advantage platform was chosen for the flexibility of the connection and for the ability to store in buffering on the internal memory, NVRAM or MRAM, real-time data which will then be processed by a central server. The connection to the sensor and machinery is made via various fieldbus, while the data processed by the WISE 5580 is sent with OPC, UA and MQTT technology to the storage server. Thanks.
So, gentlemen, where do we see this taking us in the future?
Again, in Europe, the market share of the EtherCAT will keep growing, not only for the motion applications, but also for industrial IoT applications. Especially when you consider our ability to mix the EtherCAT with other interface technologies to guarantee real-time performance while using virtualization, also address less time-critical aspects. As an open EtherCAT technology vendor, we are helping our customers to migrate this farthest industry Ethernet not only as a hardware vendor with our high-performance PC controller and the I/O, but we are also working with our software partners like Akuntis and Codices to support our customer by bringing solutions optimized for specific applications to the market.
As I said before, so local giant industrial player has more than 95% of market share here. So we looks really promising to grow EtherCAT solutions with partners together, since we're still little now. And this change is not just about we sell more, but users can get the flexibility when embrace EtherCAT solutions.
Today, there is expanding standardization in controller-to-controller communications via initiatives like OPC Unified Architecture, and to upper-level systems via embedded SQL connectivity. There is standardization in controller communications to devices and sensors via fieldbus, with EtherCAT leading the pack. The EtherCAT fieldbus enjoys a robust following by customers and suppliers alike for its high performance, broad interconnectivity, and open standard. And there's the dawning of a new age of smart sensors and devices with rich communication via protocols like IO-Link. As for what I see in the future vision for automation control, I'll name 4 areas to watch. Number 1, look for further standardization and platform independence. Number 2, look for Ethernet connectivity in many more devices, many with web servers built in for configuration, troubleshooting, and access to process data. Number 3, look for the continued broad adoption of industrial Ethernet and the industrial Internet of Things, connected devices to collect, transport, and process data. And finally, number 4, Industry 4.0 computerization of manufacturing through the principles of interconnection, information transparency, technical assistance, and decentralized decisions.
Well, that's the end of today's session. I hope that you found our discussion interesting and that it's given you some things to think about when you're designing your next control architecture. I'd like to thank Joseph, Daniel, and our partners, Stefan Zingraf from Acontis, Roberto Riccardi from Eraruno, and David Locke from Motion AI for their contributions. If you'd like to discuss an application requirement with us in more detail, please get in touch using one of the methods shown on the screen. Thanks for your time and attention, and we hope to see you again on the next InnoTalks episode.